Okay, welcome to Unit 4, Conditionals and Recursion. What I'm going to do is go over some of the PowerPoints first, and then we'll go right into the code right after that. I only have 15 minutes to broadcast, so let's get started. Okay, we start with the modulus operator, a little bit of review. And again, we talked also about integer division. And if you take a look at this example, we have 7 divided by 3. An integer divided by an integer in C++ is an integer. So again, that would just give us 2, because 3 goes into 7 twice. If we're talking about modulus division, or the modulus operator, which is the percent symbol, if we take 7 mod 3, we get the remainder. And 3 goes into 7 twice with a remainder of 1, so this will return 1. Okay, and again, all that should be reviewed. Starting with conditional, now we're allowed to have the program make a decision. And we use what we call if statements. Okay, and if you look down here, here's a simple if statement. And it says if x is greater than 0, go ahead and run this code. See out x is positive. The braces mean begin and end. Means go ahead and begin the if statement, go ahead and end the if statement, and everything between the begin and end goes with that if statement. Now this code will only run if this is true. If x is greater than 0, this code will run. If this x is less than 0, make this false, it will skip over the if statement, okay, and it will skip that piece of code. So that code only runs if x is greater than 0. If x equals 0, well, 0 is not greater than 0, so it will be skipped. Okay, we call these conditionals. Some people refer to these as if statements. And again, you can use if statements many different ways. It allows the computer to make decisions, whether to run a code or not to run a code. Comparison operators. Some of these are very familiar with, similar to algebra. Here we have the double equal symbol, which means compare. So if x equals y, so if x is 3 and y is 3, this is going to return true. If x is 3 and y is 4, this is going to return false. Okay, so we use the double equal symbol to compare. This will return true and false. Don't get that confused with one equal symbol. If it's one equal symbol, we actually take what the value of y and put it into x. 2 equals, we compare the two sides and return true or false. The next one is x is not equal to y. And we use the exclamation mark with the equal symbol, and that means not equal. The next one is x is greater than y. Very similar to algebra. X is less than y, very similar to algebra. The next one is x is greater than or equal to y, and we use the equal symbol outside on the right side of the greater than symbol. So if x is greater than or equal to y, then it will return true. If it's not, it will return false. We cannot put a line underneath the greater than symbol, so again we use the greater than symbol with the equal symbol to say greater than or equal to. And the last one, x is less than or equal to y, is the same thing. We put the equal sign on the right side of the less than symbol, saying hey, x is less than or equal to y. And again, if x is less than y, it will return true, other than, or else it will return false. Don't try to switch the equal symbol with the greater than or less than symbol. It will not work. It will cause an error. So let's take a look at an if statement. Here we have an if statement where it says, this is what we call an if-else. Here we give the computer a choice. Either run the first one, x is even, or run the second one, x is odd. So one of the two will run, but not both. So if x mod 2 equals 0, so let's say x is 6, 6 mod 2 equals 0, which is true, x is even is printed. if this is 7, 7 mod 2 equals 1, so 1 does not equal 0, so x is odd is printed. So one of these codes will run depending on if it's true or false. True, the if portion runs. False, the else portion runs. Both of them will never run at the same time. Only one, not both. You could go ahead and put an if statement inside of a function. Here we have a function, and it takes in a variable called x. And it's the exact same program on the last slide, and we compare x if it's even or if it's odd. One of the two codes will run. And then notice down below we have down here where we say 17. 17 is being passed in. We call the function down here at the bottom, and 17 comes in as x. So now x is 17, and 17 mod 2, it should see out x is odd. Notice here's where we declare the function. This is up here on top where we declare it is called the parameters. And down below where we call it in our main program is called the argument. So we take the argument 17 and we pass it into the parameter x. And x is now 17. We could change x. It does not affect 17. 17 will always be 17. So here is the wrong way. Here we have int num equals 17. We're in the main program now. And here we go ahead and call the function, and we go ahead and try to declare the variable. You can't declare a variable in a function call. You only declare the variable in a function declaration. When you go ahead and create the functions on the top, that's where you'll put int num. Here, this should be just number, not int num. So let's go to our code and look at it on code blocks. And I'll try to adjust my screen here a little bit. Here, if you notice, I have the function up here. Here, let's just start with integer division and modulus division. Okay. And if I go ahead and run this, this should go ahead and output 2 and 1, which it does. Okay. If you see up here, 2 and 1 is outputted. And that's because we took 7 divided by 3. 3 goes into 7 twice, and it just returns the integer portion. Here, this returns the remainder. Okay. I'm going to go ahead and comment that out because we don't need that anymore. Down below, again, we talked about our relational operators. Here we have double equals. Okay. Again, we compare x and y. Here we have not equals, greater than, less than, greater than or equal to, less than or equal to. Let's take a look at that first if statement that was on our slide. And I'm going to go ahead and say x. Up here I have x declared as 3. 3 is greater than 0, so it should output positive. So again, I'm going to go ahead and run this. I got to close this out first. Okay, I'm going to go ahead and run this. And again, x is positive, is outputted at the top corner. Okay, I'm going to go ahead and comment that out. And we're going to look at the second if statement. And notice it's an if else here at the bottom. And I have x mod 2 equals 0. Remember that was 3. So in this case, it should say it is odd. So the first one says it's positive. Second one says it is odd. I also called the function in this one as well. Down here, I'm passing in 6, and 6 is coming up to this function on the top. And we're taking 6 mod 2 equals 0, which is true, and it's outputting even. So let's go ahead and run this. And again, you see positive, odd, and then even. Okay. That is the first part 1 of Unit 4. Again, we talked about integer division, modulus. We talked about a simple if statement, how we use a Boolean condition that has to evaluate to true or false to run the code or not run the code. And we talked about a simple if-else where one of the codes will run, but not both of them. Okay, either x is even or x is odd. It can't be both. Okay, so one of these codes will run depending on if this is true or false. And we talked about functions again, how we're passing in an argument 6, and that argument is coming in as the parameter x. X receives that value 6, so now x equals 6, and I can do whatever I want with x. It will not affect the value down here where I called it 6. 6 will always be 6. Hope you enjoyed part 1. Part 2 will be next. Have a good day.